Hello and welcome to this webcast, Energy Efficient Infrastructure for HPC Workloads, hosted by Scientific Computing World and sponsored by AWS and NVIDIA. My name is Robert Rowe. I'm the editor of Scientific Computing World, and our guest speakers today are Andrea Rodolico, HPC Business Development Manager for Amazon Web Services, and Dion Harris, Director of Accelerated Data Center GTM at NVIDIA. Andrea is a tech industry veteran with more than 25 years of experience driving product innovation and growth strategies for GPU accelerated and high-performance computing. As a principal advanced computing specialist at AWS, Andrea develops solutions and go-to-market motions for HPC and AI ML workloads leveraging NVIDIA GPUs. Dion Harris is a director of accelerated computing go-to-market at NVIDIA, focusing on scientific computing use cases. Previously, he held various impactful product management and marketing roles in leading data center technology companies such as Dell EMC and Symantec. AWS and NVIDIA offer purpose-built compute, storage, networking, software, and services to supercharge HPC design and simulation and generative AI workloads. Improve HPC performance and reduce energy usage across your end-to-end workflows with cloud-based accelerated computing from AWS and NVIDIA. In this webcast, you will gain insights on energy-efficient HPC infrastructure from AWS and NVIDIA, the benefits of the latest technological advances such as NVIDIA GPUs, and accelerated computing libraries, frameworks, and SDKs to solve HPC workload complexity and reduce energy consumed per unit of compute hour. This event has been specifically designed for business leaders looking to maximize HPC infrastructure and improve its environmental impact. HPC and IT managers looking to build or optimize HPC infrastructure with a scalable, secure, end-to-end platform, bringing easy-to-manage hardware and software tools. And HPC users and data center operators looking to optimize HPC infrastructure with energy efficiency in mind. After the presentation, there will be a question and answer session, which anyone can use to ask our speakers a question. If the speakers do not have time to answer your question today, the information will be passed along to the relevant people so the teams can follow up at a later date. Andrea, Dion, over to you. The floor is yours.
Welcome, everyone, and thank you for joining us for this session about maximizing energy efficiency with cloud-based HPC infrastructure. My name is Andrea Rodolico, and I lead business development for accelerated computing and HPC at AWS. And I'm joined by Dion Harris from NVIDIA.
Thanks, Andrea. My name is Dion Harris. I'm the director of the Data Center HPC and AI go-to-market team. Today, we're going to talk about a lot of things. So let's maybe give a little overview of some of the things we're going to cover. So first, we'll give you some background just to help understand what are the key drivers that's really creating this heightened focus on energy efficiency and carbon footprint reduction. Then we'll talk a little bit about our joint solutions of both AWS and NVIDIA, offering solutions to our customers to help them reduce their overall energy consumption and carbon footprint. Then we'll describe some use cases of how some customers are actually deploying these technologies to actually save energy and reduce costs. And then lastly, we'll wrap things up and give you some call to actions of where you can actually go to deploy and use some of these great solutions. Sound good?
Sounds great. Let's get started.
Cool. Let's get started. So like I said, when we think about sort of what's creating this heightened focus around energy efficient, there's a couple of key drivers and trends that are happening in the broader landscape. First is you have a steep increase in overall energy prices. And that has a number of impacts, both in terms of operations, as well as just the overall efficiencies that you can get out of deploying your solutions in a data center. In addition to increasing costs, you also have a heightened awareness from a policy and regulation standpoint in terms of reducing carbon emissions. And there's been a lot of discussions around how data centers are contributing to overall carbon emissions when you look at the power consumption, as well as how it impacts the overall environment. And then last, you have another issue, which is basically the growth in demand. Whether it's HPC or AI, the demand for digital infrastructure has been skyrocketing over the last several years and perhaps even the last decade. And you're looking at the example on the right, this is just highlighting AI as one use case, but you can understand that the growth in the AI models is having a direct correlation with the overall compute resources that's required and therefore requiring more energy. So, Andrea, why don't you tell us a little bit about what we're seeing in terms of what's happening at the cloud level in terms of the data center dynamics there as well?
Absolutely. So for us, energy efficiency is very important, both because we deeply care about sustainability, but also because our customers are seeing the cloud as a vehicle to achieve their own sustainability goals. So in order to elaborate this subject, we look at sustainability through multiple lenses. Sustainability of the cloud refers to our efforts to increase efficiency of our data center and operations. For example, Amazon has invested in over 500 renewable energy projects, totaling over 28 gigawatts of clean energy that directly impacts carbon emissions of the workloads running on the cloud. When migrating to cloud, customers of all sizes immediately take advantage of these investments and lower their footprint. However, customers also come to the cloud with their own specific sustainability goals and projects. So sustainability through the cloud refers to how AWS supports these efforts through architecture, solutions, and partners to increase our customers' operational efficiency and lower carbon footprint for them and their value chain. Last, the third lens refers to how sustainability is actually one of the 6 pillars of our well-architecture framework, which is a collection of best practices that AWS uses to support customers to design, implement, and operate their solutions at scale on AWS. And this is what we mean by sustainability in the cloud, and helps drive choices that are more sustainable and more long-term, beneficial for their sustainability goals. 4.1 research, when compared, the enterprise data centers across different continents with how workloads are running in the cloud, concluded that AWS can lower the carbon footprint of average on-premise data centers by nearly 80% today, and 96% once AWS will be powered with 100% renewable energy, which is, we're on schedule to accomplish by 2025, which seems crazy, but it's just next year. Wow. And so why is AWS so efficient? The energy savings result from both servers and data center facilities. We pay great attention to power optimization, integrating the latest and greatest technologies and components. So newer chips means better, efficiency and better power, better results per power. Our utilization of the infrastructure is also higher than average, since we leverage the ability to share and dynamically reallocate workloads and resources among different customers. At the facility level, we design so that energy is consumed less for cooling and power distribution, and all this basically translates into less energy used to perform the same unit of work. So while the efficiency of the cloud changes depending on the condition of the different European, US, and Asia Pacific situations, in general, we observe that enterprise infrastructure tend to be more fragmented, and while there's efficiency initiative happening there as well, they tend to be narrower in focus and harder to scale. On the other end, AWS is fully focused on delivering IT services at scale. So maximizing energy efficiency means reducing power costs, and the lower costs, given the scale with which we run, can directly impact our bottom line. Therefore, we have a strong incentive to make our entire technical organization work together, from design to operation, from servers to data centers, to continuously optimize and improve energy efficiency, water, and resource consumption. So how does this intersect HPC? Our customers have been migrating all kinds of HPC workloads to the cloud, from product design in automotive and aerospace and manufacturing, to weather modeling, climate simulations, a large number of workloads in healthcare life science, like genome sequencing or molecular modeling, all stages of semiconductor design, energy workloads from more renewable energies to more traditional seismic processing and reservoir modeling. So all kinds of workloads have been continuously migrating to AWS, and generative AI is changing the game also in terms of the scale and complexity of these workloads in a non-linear way. So this has brought some of the crown jewels of our customers, but these type of workloads are not homogeneous at all. So customers need to run large computations on top of very large data sets. Their engineers and the scientists need to work on tightly coupled workloads where a problem is split in different components and processed in parallel by multiple nodes, or loosely coupled workloads where different problems are executed independently by computers, but in very large numbers, like 10,000s of millions of units, so that they can explore different spaces and optimization opportunities. And HPC has been leveraging GPUs for a long time today. I mean, for example, in the visualization space, GPUs have enabled end users to process these large data sets and visualize them and take decisions based on these findings. And today, of course, they're migrating these kind of GPUs to the cloud with virtual workstations to perform the same tasks. However, with the advent of machine learning, the accelerated computing has been spreading across all types of workloads and is accelerated, no pun intended, the pace at which these resources are consumed and sought after by end users for their HPC and machine learning requirements. So, Dion, how do GPUs impact the energy efficiency of the equation now going forward?
Yeah, no, thanks for the question, Andrea. When we look at sort of what drove the need for accelerated computing, we have to start there. And when we look at sort of as computing evolved, for years and years, we got additional performance and improvement just out of Moore's law, right? So you were able to get more transistors within the smaller area on the die, and you would deliver that innovation year over year, and that allowed us to generate more performance. And most of the industries relied on that. However, we've seen that effect starting to taper out around the early 2000s, and that really forced a lot of not just data centers, but technology builders and providers to really think differently about how they were going to architect their computing solutions. And so with that, NVIDIA pioneered the whole computing model of accelerated computing specifically to help get more performance out of the same power envelope. So accelerated computing was the first step. And then, of course, as we started to build these accelerators, again, taking a GPU, pairing it with a CPU within a system, we realized that to deliver at HPC scales, you really needed to take advantage of all those underlying great best practices of scaling workloads across multiple systems or multiple GPUs for that matter. So there was lots of innovation around the networking to deliver the production performance at scale. But more recently, there's been a new tool that's been made available to scientists and overall technologists as a whole, which is AI. Because AI is yet another tool that delivers much more performance, like orders of magnitude levels of performance. And in terms of their power efficiency, it's truly incredible and transformational in terms of what it can do for the overall economics of the data center. So accelerated computing is truly the path to sustainable computing. And so next, I think we'll talk a little bit about how those dynamics are playing out in terms of specific, sort of areas of computing. So first on the left, you have traditional simulation. And of course, like I said, accelerated computing was born out of the idea that you can take a GPU, pair it with the CPU, and parallelize the code and make an application run faster. And when it runs faster, it actually can consume less energy because you're looking at the energy, not the power consumption of the device. So that's a fundamental sort of concept when you think about accelerated computing, because most people will look at it and say, okay, I have a GPU, I'm adding power to the server. How am I saving power? The reason you're saving power is you're reducing dramatically the time you're running those jobs. And so for traditional simulation, we see speed ups anywhere from 10 to 100x and that has direct impact in terms of energy efficiency. And then on the far right, like I mentioned, AI is the latest and greatest tool that is really starting to transform what's possible in the data center. And this truly has order of a magnitude's level of impact when we look at the various domains that's being applied in, whether it's life sciences and molecular dynamics, climate and weather, and we're seeing tons of innovation that's happening across the board, even in sort of traditional heavy industry. So these two phenomena coming together, accelerated computing plus AI, are going to drive efficiency throughout the data center. So now we'll take a look at some actual customer examples and how they were able to leverage these technologies to deliver benefits. So first, we'll take a look at Whiffle. And again, as I mentioned before, these technologies are being used across a number of domains, a number of industries. And so we just have sort of a very small selection here that we've been able to highlight that are using both the AWS platform along with NVIDIA to deliver some of these benefits. So first, like I said, I'll take a look at Whiffle, which is using traditional simulation. As I described earlier, accelerated computing was born out of the need to deliver increased performance within the same power envelope. And so what they were able to do is, in terms of renewables energy, wind is one of the most promising, sources of renewable energy. However, there is lots of concern of understanding how these wind farms will impact the broader environment. And so when we look at how they were able to use accelerated computing and the AWS infrastructure to quickly model this large eddy simulation of a wind farm, it allowed them to reduce their overall time for the actual simulation itself, but also dramatically reduce its energy consumption in running those simulations. So this is another example, again, where accelerated computing is bringing sort of the dual benefit of time to solution as well as reduced energy consumption. Siemens Energy is another example where they were building a heat recovery steam generator. And one of the key things about industrial plants is that the biggest enemy of an industrial plant is unplanned downtime, because that creates traditional costs and waste. And so they were able to leverage AI to model the fluid dynamics and flows throughout the pipe infrastructure. And what that allowed them to do is have a much closer and more granular view and understanding of the predictive impacts of the flow control, the chemical mix that was running through the pipes. And so that gave them the opportunity to build a model. And so they were able to use AI, which is basically built on a platform called Modulus that NVIDIA offers to build physics ML-based models, along with AWS's infrastructure and the Kubernetes stack management, the elastic Kubernetes scalable solution there, to build a digital twin of their entire plant, leveraging AI to simulate in real time to quickly understand the impacts. And so it took those simulations that they were running to understand the predictive maintenance issues from 8 weeks to just hours. And so that sort of transformation in terms of insight allowed them not only to get faster results, but also reduce the energy and consumption in delivering those results. So again, incredible results that our customers are seeing together, and again, built on AWS's platform, along with NVIDIA's accelerated computing and AI solutions. So maybe, Andre, you can tell us a little bit more about that incredible AWS platform and what customers are using to deliver these results.
More than happy. So it's very exciting to hear customers talk about the improvements they can get from accelerated computing on their traditional workload either. For example, our CFD customers are telling us that moving from CPUs to GPUs, activities that took a couple of weeks now can take 2-3 hours during the day. And so it's a massive productivity improvement. So in HPC, AWS has invested for a long time, but the pillars of HPC are the same as they've always been. You need great compute, you need storage, you need great networking, and you need flexible orchestration and visualization solutions. In the next few slides, I'm going to try to introduce some of these technologies and partnerships that make these results possible. So on the compute side, AWS customers are enjoying a wide variety of options. AWS offers hundreds of instances, from CPU-based to accelerator-based to GPU-based, of course. And in the NVIDIA domain, we offer two major families of instances, and our customers can take advantage of our G instances that are, G stands for graphics. We're born as graphics optimized, so they do, for example, virtual workstations on them. But the characteristics of the NVIDIA chips behind the scene, A10G and L4, are good also for, machine learning inference, as well as single precision floating point. So they're very versatile, and customers love to use them for these kind of use cases. However, we also offer the top of the range P instances that are featuring both A100s and the latest generation H100 GPUs from NVIDIA that are optimally dimensioned and sized for high-end machine learning training, and also work really well for double precision floating point computing for high-performance computing needs. The large P instances are in such high demand that we even had to innovate on the way consumption can work on these instances. So besides offering them on demand and as long-term commitments, we also have introduced the EC2 capacity blocks for ML, which allow customers to reserve these instances on a daily basis to cope with their big training workloads and similar needs. So behind the scene, of course, the connectivity tissue is the key component of every successful HPC solution. But let me digress for a second on the networking side, because the network for AWS is a foundational, critical component that empowers our ability to innovate and deliver reliable and secure services to customers. So very early on, AWS decided that in order to be able to innovate at the depth and scale and pace that the customer were asking, we had to own the full stack. The whole networking complexity needed to be under our control. So we started building our own networking hardware, and both on the card side and on the switch. We have our own fabric. We control all the stack from the hypervisor all the way through drivers and even the protocols that are running on the network. This gave us a great opportunity when HPC started migrating to the cloud. The requirements that customers were bringing was for low latency, low jitter, and high bandwidth. And since we were able to control that end-to-end, we were able to implement the Elastic Fabric Adapter, which is basically a network device that you can attach to any of your latest generation Amazon EC2 instances. And this bypasses the kernel and allows us to implement all high-performance solutions like GPU Direct, RDMA, and we leverage Leap Fabric to directly integrate with the most popular MPI stacks and Nickel, so that customers can enjoy the enhanced performance of EFA without any change to their application, their code, and having just the best results from the network that we offer. Such network has multipath routings, has a very sophisticated cloud scale congestion control, and of course it can scale up to 400 gigabytes per NIC. So it is very well suited to address all types of HPC workloads. As you can see on the right, the Star CCM Plus is a very popular computational fluid dynamics software, and it shows super linear scalability for well over 400 instances, or 40,000 cores, if you like. But this same network is the one that we have been using behind the most demanding training and machine learning workloads, including foundational model training and fine-tuning with excellent results. So, of course, there's no HPC without a lot of critical storage. And customers have been asking AWS to really deliver custom and purpose-fit storage for their purpose for their workloads. So Lustre is a very popular storage solution that has been used for many years in HPC. And this was the first managed file system that we had on AWS under the family of FSx, so FSx Lustre. And this is optimized for large throughput, very scalable, high concurrent access scenarios. But customers in EDA, for example, have been very vocal that NetApp was a familiar technology that provided the right integration, the right performance for these very, very demanding workloads. And so we also implemented another family member of the FSx family that provides a NetApp on-top functionality. And so it's suitable for very large IOPS workloads with sub-millisecond latency. We also have a version of the Lustre technology that acts like a burst buffer for HPC called Amazon FileCache, which enables you to connect NFS servers everywhere on-prem or on the cloud and make them available to a high-performance computing facility with a very high throughput and better latency. So besides these, managed services, we have a large number of other options and also partnerships with companies like Weka that provides, custom-built and purpose-built solutions for specific workloads that are very, very efficient. But one thing that immediately meet the eye is that these managed services innovate behind the scene both to improve performance, lower cost, but also to improve efficiency. For example, our Lustre customers, without changing anything in their daily operations, were able to benefit from a much lower carbon footprint when we migrated our Lustre services from traditional CPUs to ARM-based Graviton chips that we are building in our data center. And so this continuous innovation is happening completely transparently to the usage of HPC applications and workloads on top of that. Now, there's no real HPC without a good usability layer on top that orchestrates and organize all the workloads. And in this space, our customers are enjoying a wide selection of options. Some come from our partners like Rescale or Total CAE or Siemens and Ansys and Ronin. So all partners that are focusing their solutions to optimize certain scenarios. But we also have our own managed services at AWS. So our customers can benefit from, for example, if they are coming from a traditional HPC cluster with the traditional HPC scheduler, AWS Parallel Cluster can quickly reproduce that familiar experience within the cloud, enabling elasticity and integrated storage and compute and authentication in a very simple, quickly deployable infrastructure. However, some customers approach the migration with a modernization intent. They want, for example, to migrate to DevOps and containers. In this case, tools like AWS Batch enable native management of containers at massive scales, offering queuing system that optimize resource provisioning at, again, the ability to run millions of cores or hundreds or thousands of GPUs within their environment. However, those customers that are specifically focused to train a machine learning model, in particular foundation models, enjoy even more the ability to have a dedicated, super optimized solution through Amazon SageMaker HyperPod, which is a very resilient distributed training environment that streamlines all resource super operations for enabling machine learning toolkits and libraries to perform optimally at the very high scale. Because of these and other innovations, they have resonated very well with the HPC customers, and we are very proud to have been nominated Best HPC Cluster, HPC Cloud Platform by HPC Reader's Choice Award of HPC Wire for 6 years in a row. We obviously want to continue to delight HPC customers, and therefore we continue to invest in HPC and machine learning solutions. Strategic partners like NVIDIA are a key driver to accelerate these innovations. So, Dion, what solutions can customers expect to see on AWS going forward?
Yeah, no, great. That's a great question. And when we look at sort of how we've built our platform on top of AWS, like I said, leveraging all the great technologies that you just covered. And again, we bring sort of our solution to bear to help deliver value for customers. The first thing that we really want to drive home and help, and I'm sure users understand, is that accelerated computing is a full stack problem and solution. In other words, it requires innovation at every layer, or coordinated innovation, I should say, across every layer of the application stack and the data center. And so you mentioned a lot of the great work that AWS is doing. NVIDIA has developed its own HPC SDK, which includes things like Nickel and like GPU RDMA to help make those integrations and communication across the infrastructure much more seamless for the infrastructure to truly behave as a single system. We've also have a number of developer tools that are built to help optimize productivity of developers. And of course, it doesn't stop there. Like I mentioned, it is a full stack problem and solution. Therefore, a lot of our innovation is happening domain by domain. So when you look at sort of how we're integrating our solutions with AWS to go and tackle domain-specific problems, like we built, our Rapids platform that is built around data processing and analytics, which is also a heavy workload within HPC audiences. Of course, you talked about some of the CAE and EDA type workloads that are happening in industrial HPC. And of course, we built a number of tools and integrations there to help make that more seamless and more performant. And of course, we've optimized our stack for each of those particular ISVs to make sure that we can get the most out of that. Climate simulations is another key one where we're bringing not just traditional numerical-based weather prediction, but leveraging new tools like AI to help go and tackle some of these very big problems in a much more efficient fashion. Quantum computing is another area that's really starting to take off within the overall HPC landscape. And of course, we're right there delivering quantum circuit simulation tools, integrations with Amazon's Bracket platform, for example, to really deliver a platform that every researcher can access to further their developments. And of course, like I said, the combination of industrial HPC and traditional open science is really starting to blur, because you see lots of your large commercial HPC organizations adopting and leveraging some of those same core technologies, looking, for example, like Romax and Milk. And so we're innovating in all layers of the stack. And again, building on top of the great platform that AWS has built to create a fully integrated solution. So next, maybe I'll double click just to describe some of the efficiencies that we deliver through the GPUs themselves. So first, Hopper is the world's most advanced, accelerated platform on the market today. And the reason that isn't because, it's a beautiful GPU. It's really driven by the fact that it creates real value. And so when we looked at a number of key, HPC applications I mentioned, like Romax, Milk, WRF, and some of the traditional simulation workloads, in addition to AI and looking at a mix of AI workloads, inference training across, large language models, across vision models, we're able to show that the H100 platform can generate 20x more energy efficiency, 20x more performance per watt for AI and HPC workloads. That's the real driver of the demand for these systems. It's not just the fact that they speed up your application, but it's the fact that they speed up your application in a much more energy efficient and cost-effective way. Now, what does that mean in terms of impact on the environment? We've been talking a lot about the data center, but a lot of concern is really about how does the data center impact the environment? And those savings can generate roughly 8.5 million metric tons of CO2 emissions. And again, that's where we're showing that we can actually reclaim lots of wasted time, energy, and resources. And that equates to roughly about 1.7 million homes of electricity use. And of course, that varies with region, but this is really just trying to paint the picture that, when we describe energy efficiency, we're talking orders of magnitude level of difference, not just, percentage levels of difference. And that's really what's the key driver of energy of the accelerated platform and the work that we're doing with AWS. So, in addition to Hopper, we made some incredible announcements recently at GTC. And so next, I'll talk a little bit about that. So at GTC, we announced Blackwell. And Blackwell is an incredible platform. And as I described before, it involves, innovation at every layer of the stack. And we're pleased to announce that we're going to be deploying that on that AWS infrastructure. So we highlighted our GB200 NVL72 solution, and it has some incredible innovations at an architectural level. So first, the processor itself has been built to be the largest, most performant GPU on the market, over 200 billion transistors. So again, the largest GPU, a large reticle size GPU that's connected two of those dies together. That creates an incredible performance and seamless performance across both. We've also implemented something called our second-gen transformer engine. And this is incredible, especially for AI inference, which is another workload that's driving a lot of the compute cycles. And so this is really a key improvement in terms of performance and energy efficiency, because it's allowing us to leverage lower precision levels and using software to optimize that across the entire data center. And of course, when you talk about efficiency of the data center, you also have to look at the reliability. And so we've done a lot of work to make sure that we can build manageability into the GPU infrastructure so that it can reduce the overall unplanned downtime. And it can also make sure that your jobs are completing, without any interruption. And NVLink is another key technology that helps make these multiple GPUs behave as a single GPU. And so we've increased the overall bandwidth and speed and efficiency of our NVLink platform to create even more performance. And all of that together, along with some other innovations, translates into more energy efficiency. So GB200 compared to Hopper, which I just described as today's leading HPC and AI platform, GB200 NVL72 is 25 times more energy efficient than Hopper. And again, Hopper is the state of the art in terms of GPUs, and that's not even comparing against a CPU-based solution. So it's really incredible what we're doing here. And again, we're excited to say that we're partnering with AWS to bring this solution to market through the AWS cloud. But again, it's not just the hardware. So next, I'll talk a little bit about some of the innovations that we're doing on the software level to also drive efficiency. So as I mentioned, when I showed that stack diagram, we're innovating at all layers of the architecture to drive more performance and efficiency. So in this case, we're highlighting a solution that we have called TRT LLM. And as mentioned, when you're deploying, AI models, you're using inference. And that is really one of the biggest drivers of compute cycles, because again, you train a model once, but you deploy and use it, over thousands of users and scaled use cases. And so what TRT LLM is able to do is it can actually reduce the overall cost and energy by roughly 3 to 5x. And so that's just using software alone. And by using the underlying hardware in a much more efficient and performant way, it's able to deliver more performance at lower cost and lower energy. So again, you get that incredible benefit of accelerated computing, and you get the sort of the underlying, sort of increased efficiency that you can reduce your carbon footprint and have a better overall impact on the environment. So, like I mentioned, it's a full stack problem. And of course, we're bringing these solutions to AWS. And so maybe, Andreas, you can tell us a little bit about some of the great solutions that are coming based on what I've done, some of what I just covered.
Yeah, it's super exciting to have a roundup of all the recent announcements. It's the innovation rubber meeting the road. And over the last few weeks, we had a very good set of announcements of NVIDIA-powered technologies. So we started with the general availability of the G6 instance a few weeks back. It's the first that supports the L4 processor from NVIDIA. And it's great for next generation instance for inference and graphics. However, we already have announced for the residual part of the year the availability also of the G6E, which is an extended version of the G6 based on L40S. It has double the GPU memory and increased memory bandwidth, so to further improve performance and energy efficiency of workloads that are leveraging the G instance family. Of course, the P5 instances have been wildly popular with our customers, so we are thinking about evolving that into two different dimensions and directions. First is to couple the current H100 offering with the H200 offering from NVIDIA that will be available again later this year through systems that have 8 H200 GPUs and therefore with a significant increase in GPU memory per GPU. And this will enable, very incremental benefits to the training workloads so that they can go and train more complex vision models and similar. However, we also plan to release the next generation based on Blackwell 100, which will support the Blackwell GPUs and again, increase performance and increase GPU memory, which is critical for our customers. But we also announced at GTC to embrace the GB200 platform, which basically combines the latest and greatest GPUs with the ARM super efficient and very high performance processors that are composed into these super chips. And we will also deploy on AWS the NVL72 technology. So customers will have the benefits of both the EFA performance scaling up to, that today already scales up to 3200 gigabit on existing infrastructure, and it will go even further. But we'll also couple that with NVLink to build, unified memory domains of almost 20 terabytes that customers can use directly for their performance improvements. The relationship with NVIDIA has become even more strategic, and we announced Project SIBA, that is basically an AI supercomputer that will be built exclusively on AWS, will be powered by the DGX Cloud, SDKs and facilities, and will feature over 20,700 GB200 super chips, and it's capable of processing over 400 exaflops of compute. That will be dedicated to NVIDIA's own AI R&D. So, Dion, I wonder, the kind of innovations that your team will be able to accomplish with such immense compute power at their fingertips.
We're excited about it.
So, to sum it up, we are incredibly excited and humbled to empower our customers to innovate and reshape HPC across so many industries, so many use cases. Through our strategic partnership with NVIDIA, we have been able to innovate at an unprecedented pace, but without sacrificing energy efficiency. That's super important for our mission. In the cloud, customers can have both top performance while pursuing their sustainability goals fully. So they can double down on just focusing on delivering groundbreaking results and accomplish them without negative impact to the planet and to our overall health.
Yeah, and I mean, I think NVIDIA is very, very proud to be sort of the pioneer and champion of accelerated computing and AI, and we view these as instrumental tools to help science and help the overall computing industry reclaim tons of computing cycles and wasted energy by leveraging GPU acceleration as a first starting point. And through that, like I said, you can save anywhere between 3x to 30x or 40x actual power that's being consumed. So much more efficiency just by adopting accelerated computing. And we're working with a number of applications and developers to start that path toward accelerated computing. And AI, of course, is another tool that is being leveraged to actually reclaim lots of computing cycles. And so, I think the key takeaway here today is that, both AI and GPU acceleration are going to have a huge role to play in terms of moving toward that path of sustainable computing. And again, we're excited to partner with AWS to build, market-leading solutions that can help our customers, deliver the performance they need to run their businesses and to actually deliver the innovation that takes place in scientific computing, but also reduce the impact on the environment and do it responsibly. So again, great solutions, and very exciting to see all of our customers and some of the great work they're doing with the platforms. And so next, we can definitely, give them lots more to go and digest. So you can learn more here. There's some QR codes where you can get some more information on some of the great insights we've shared here today, along with some of the solutions that we highlighted as well. So we had a great conversation today, Andrea. I don't know if you have any closing words, but again, I think this is hopefully, our customers will take and run with this and create some more great breakthroughs and obviously create some more energy efficiency solutions that will drive the market.
And I'm incredibly thankful for the time everyone has invested to hear about these innovations and the continuous drive to lower the carbon footprint and improve energy efficiency of HPC and machine learning workloads. So without further ado, if we want, we can go into a Q&A session and hear more about what else we have to cover and what topics are most interesting.
Thank you very much to Andrea and Dion for their very informative presentation. We will now move over to our question and answer session. So without further ado, first, I have a question here. Does AI really save power in data centers? For whoever wants to take a shot at that one.
Sure. Maybe I can take a quick stab at that one. I think like any answer, it depends, right? And what I mean, it depends on sort of what that data center is trying to optimize for. If the data center is trying to optimize for cost, for example, and they're trying to get sort of the overall best performance for the cost that they can deploy a solution. We have lots of data points that suggest that when optimizing a data center level performance for cost, we can also reduce power consumption as well. Similarly, if a data center is trying to basically deliver the most performance they can for the same power consumption, again, having the most efficient platform will allow those users to get the most performance while maintaining their overall power footprint. So I think the key point here is that, technologies like accelerated computing and AI can be the most efficient way of simulating, of modeling, of running various workloads, but the implementation is going to dictate whether you actually save consumption or you're optimizing for a different variable. So I'll let Andrea take another stab at that. But I think the key point here is, these technologies are the most efficient ways to deliver some of these workloads.
Yeah, I concur. At the end of the day, to get a certain amount of job done, you can get it with the lower power if you can take advantage of accelerated computing. However, the mileage will vary depending on what is, again, the purpose of the optimization you're trying to accomplish.
Okay, thanks. So that makes a lot of sense. And the next question, what are the key reasons that you see customers moving their HPC workloads to the cloud?
Well, there's actually multiple reasons. It all starts with the HPC customers often being, queued up, waiting for resources. And so very often the first optimization dimension is really to be able to get access to the latest and greatest capacity in an elastic way. In particular, GPUs are it's very hard to get hold of latest and greatest on your data center because you have to commit to that capacity for long term. So on the cloud, you can always get the latest and use it for as much as you need, pay for what you need, and then provide the results to the users. So that is definitely one critical component of the decisions. However, there's also a lot of customers that understand that running a data center for HPC is a means to an end. Their core business is not really running data center, it's getting the results that system produce. So having the ability to migrate to the cloud and just focus on the core business has been very appreciated. So combining the two really gives very compelling reasons why customers are migrating.
And are there any specific HPC workloads that are ideal to run on GPUs in the cloud on AWS?
So maybe I'll take a crack at that one. So accelerated computing and GPU accelerated computing is basically a domain by domain effort. And what I mean by that is, pairing a GPU with a CPU to, deliver application performance requires, integration at the application level and system level. And so you're going to see, different levels of acceleration based on the various domains and the applications. So I'll throw a couple out there just for consideration. One is molecular dynamics, for example. Some of these codes are recently developed and are very optimizable on some of the parallel processing methodologies that we use with CUDA and with our GPUs. So you'll see speed ups that are in the double digit, even triple digit range in some cases. You also have some other applications like traditional ISV, CAE and CFD type workloads. And again, it's going to vary based on the type of code it is and how it's written and developed and how much it can take advantage of the parallel programming features of a GPU. Now, when we talk about HPC, traditional simulation is a core workload. And so whether it's climate sim, I mentioned molecular dynamics, using some of the engineering applications. Again, we've spent decades working with a number of those developers in ISV communities to accelerate those applications. But HPC is much more than traditional simulation. I think AI is now sort of the new tool for science. You look at how it's being used in climate and weather. You look at how it's being used for drug discovery. We're starting to see it also show up in a lot of aviation and engineering applications. So the landscape of HPC as we know it is dramatically changing. And so we think a lot of those sort of new and evolving workloads like data processing, AI, quantum simulation is another one that we hear a lot about now recently. So we see, this wide range of workloads that are now driving, sort of scientific computing, really seeing, tremendous speed ups on the GPU accelerated platform. And then of course, and I'll let Andreas speak to this as well, but the fact that we're partnering with AWS to deliver the breadth and depth of our accelerated platform and making sure that, again, all of the software optimizations that we've done that are domain specific, because that's really where we've invested, a lot of our time and innovation over the years, is working to optimize GROMACS, working to optimize, WRF or ICON, which is another climate and weather simulation platform. So making sure that we've worked with AWS and our end users to provide a software stack that's optimized for all these various codes that we've worked with over the years is what really delivers the performance and sort of the acceleration benefits.
Yes, and this relationship both with the ISVs to really help them accelerate and deliver this acceleration easily to the customers, as well as startups, has been really useful. I mean, we have a lot of innovation coming from startups that are trying to invent and change the way people has always done certain things, as you mentioned, weather simulation and similar. And they are born in the cloud. So they really are going to the cloud to unleash their creativity without all the upfront investments that are required when you are getting into HPC. So that is a very positive reinforcing function of getting the latest innovations, the latest codes that these startups are running, already tested on the latest generation of GPUs and delivering this great energy efficiency and acceleration.
Which CFD code was used for an LES case by Whiffle? Don't know if you can we kind of go back to that a little bit.
Dion, do you have that detail? I think they have a custom code based on LES, and they were running a specific model called Harmony Arome, I think, but I wasn't privy to that specific project.
Yeah, and if we could pass all these questions, will be passed along to our team. So if they can't answer at the moment, then we'll be able to come back to you at a later date.
Yeah, and the actual name escapes me right now, but I think you're spot on there, Andrea. And they like I said, we can get some more details there in a follow-up for sure.
Absolutely, thank you. And how are AWS and NVIDIA partnering to innovate solutions for customers to run HPC workloads faster and more sustainably in the cloud?
Oh, well, I'll take the AWS angle first, and maybe Dion, you can add on the NVIDIA side. NVIDIA and AWS go back a long time. It was well before I joined AWS. NVIDIA was the first to, AWS was the first to release an NVIDIA-powered instance more than 10 years ago. So the engineering collaboration has been very tight. We always try to challenge each other on the next generation architectures and instances to make sure that we are not, we are ahead of the pack and release the latest as soon as we are able to hit the market with them. But the collaboration doesn't stop on the hardware side. We have also worked a lot to, for example, release the NVIDIA software stacks that are as rich as their GPUs on AWS, so starting with the GPU cloud as well as the enterprise solutions. So there's many dimensions. Dion, anything you want to call out about that?
Well, again, I think in terms of, like I said, delivering energy efficiency, that's always sort of at the sort of front of our considerations as we're innovating across our total platform, including how we integrate with AWS. And so I think as you look at sort of the progress we've made, year over year, gen over gen, we're continuing to push the boundaries of not just performance, but energy efficiency. And again, like I mentioned during the presentation, that's really one of the core tenets of accelerated computing and AI is how can we deliver more performance, but in a more efficient way. So again, I think that's a key driver for how we approach innovation. Okay.
And we've got a question here about startups and kind of how startups can approach you, potential collaborations or to work with you guys. What are your thoughts on that?
Oh, well, it's startups are really have a cherished role in our relationship with customers because they are part of the reason why AWS has been so successful. So we have several programs that allow startups to engage both on the incentives like credits that can be used to test the platform in different ways, as well as specific programs to improve joint go-to-market and similar activities. By just opening an account and getting in touch with the account manager and mentioning that you're interested in HPC or AI/ML, you can then get access to the right engineering resources, the experts, and the solution architects to help you think through your architectures and design for efficiency and performance on GPUs.
Yeah, I mean, and from NVIDIA's standpoint, startups are really sort of, in our minds, the breeding ground of innovation. And so, we work with various startups on a number of different platforms. Obviously, we have our own Inception platform, which is really about engaging directly with startups and helping them adopt various, acceleration technologies. But even beyond that, there's various hackathons, various engagement opportunities that we have throughout the year that are targeted specifically at engaging with the startup community. So I'd say definitely be on the lookout for those in region and see how you can kind of plug in there. But I think I echo Andrea's sentiments in that, NVIDIA recognizes that, a platform for innovation needs new ideas, needs new insights. And so, we view startups as a key source of that for sure.
Absolutely. And finally, we've talked a little bit about applications that are ideal to be accelerated. What about applications that it's not easy to accelerate? Is there a way to reduce energy consumption without degradation of preferences and performance?
Yeah, that's definitely when we talked about the efficiency and the sustainability of the cloud, that's exactly how you can, get a step up on any type of workloads, accelerated or not. The fact that we have platforms that are shared among, for example, multiple customers to be able to, have better efficiency of whatever capacity we are delivering is one of the key elements. We also share with NVIDIA a strong focus on ARM architecture, which is more energy efficient when it comes to performance per watt. Not as efficient as a GPU, but certainly a good step up. And so, for example, some applications are also migrating to Graviton, which is our ARM implementation, and we are looking forward to see that also expanding to Grace Blackwell once it will hit on the platform. So those are some of the dimensions that can be used, and again, you can bring the workloads and then pick for each kind of use case and each kind of application the right target that has the best price, performance, and efficiency that you're seeking.
Yeah, and just to add to that and echo, I think those exact sentiments in that, as we look at various applications that either have legacy code bases that are, take longer or more effort to port to a GPU, we have seen lots of energy efficiency benefits in one leveraging like the ARM-based CPU platform, like Andre alluded to. And then also, as we developed this sort of our super chip-based architecture, we found that it really is an interesting on-ramp to accelerated applications. So in other words, if you have our Grace, right now Grace Hopper, but soon to be Grace Blackwell, which we'll be deploying in AWS, we've seen that platform be very useful for customers and developers who can start out their application on the Grace, CPU, leveraging the 72 cores that are there to deliver, traditional CPU performance. But as they move layers of the application or different parts of the application to the GPU, it gives them a seamless platform to build and develop to gain that acceleration over time. So I agree with Andrea said, we look for different ways that we can help customers optimize the base infrastructure as core, making sure that you have a strong, source of renewables, very efficient data center infrastructure operations, and we rely on partners like AWS to provide that. And then on the computing side, we look at optimizing the CPU, we look at optimizing the GPU, we make sure that, we can provide software, because that's another key element that really does deliver lots of performance and efficiency benefits as well. So we're trying to optimize at all of those levels to deliver the efficiency that customers require.
Great. Thank you very much for your answers there for our Q&A. This brings us to the end of today's webcast. I'd just like to, many thanks to our speakers, Andrea and Dion. This content will remain live on the Scientific Computing World website at www.scientific-computing.com for the next 12 months. So please spread the word if you have enjoyed this presentation. Of course, please note that the live question and answer session will not function if you are listening on demand. Once again, thanks very much to our speakers, Andrea and Dion, and our sponsors, AWS and NVIDIA. Thank you all for listening, and goodbye.